So my background is actually in material engineering. I studied material engineering as an undergrad in the UK, and I really loved it. I love everything about its tactility, the fact you can pick something up and know how it performs and how it behaves. And so I then did a PhD in biomaterials where I specialised in additive manufacturing, and then I've continued to study different fields of material science throughout my career. So I worked in X-ray tomography for a few years, and then I developed some technical glasses for optical applications, and now I'm working in aluminium. I think I have a real passion for looking at sustainability, and I think aluminium as an alloy has so much potential in development to see real changes in a whole host of applications, be it transport, be it the aerospace industry. It has so much potential to create real changes in terms of CO2 emissions and things that as a society we really need to work on and move forward in. I think some of the big challenges from working with aluminiums are the alloying additions that people are looking at to utilise to keep them performing in the way that they will at the end of their life cycles. So current work is looking to develop improve the strength and improve the toughness of these materials. But the problem is that the alloy additions that people are making, how is that going to affect its later life? And are we going to be able to keep those properties after the life cycle is finished? So the recyclability of those materials, how are they going to work? Can we keep them as they are, or are we going to have to downgrade them into other applications, which is a waste of effort and a waste of energy? So I think the real challenges moving forward are going to be about keeping the material properties in their first life and their lives after. I think potential breakthroughs in the aluminium field are really going to be in fundamental alloying changes, so looking at how we can improve the strength of these materials. There's some really interesting work in metal ceramic composites coming out where they've used reinforcement phases to really enhance the properties that we're seeing in aluminiums. And I think growth in this sector is really going to see changes in the transport industry, the aerospace industry, where we can apply these materials into new fields. I think the most interesting research fields currently in aluminiums are the use of novel elements to see real changes in mechanical structure and properties. So the development of novel additions, titanium borates are an interesting one at the moment. Understanding what that does to the microstructure and how these materials behave is really exciting, and I think that we'll see some interesting developments in the next few years in those kind of fields. People are looking at a whole host of things, so be it rare earth elements, be it new ceramics, be it a whole host of things are being incorporated at the moment. There's some really interesting work on scandium, erbium's being incorporated. Some of the talks here at the ICAA have really broadened the scope, I think, of what researchers have been doing before, and I think that in the longer term we'll see really interesting changes in mechanical properties like higher strengths, better fatigue properties, better high temperature properties, better corrosion resistance. And I think all of these changes are starting to feed back from the academic industry into industrial users and the longer term products for services. As a young academic working in material science, I think what I've learned from my career is that you have to do something that you love, and I love problem solving. That's basically what my career is. Someone comes to me and says, I need a material that has these properties, what can you do? And you have to think outside of the box, and you're challenged every day to work harder, think better, be more creative. And I think that the only way we'll see continued growth in this field is by recruiting talented young people. And I think that's one of the big struggles, especially in engineering, that people don't really see our career as an exciting one, which is the stupidest thing ever, because it's fantastic. We solve problems every day for world, real-life applications, be it the biomedical sector, be it aerospace, be it power, see it anything. We have skills that are transferable to all of these sectors, and we make real-life changes. And I think if you want a job where you can see a difference and have passion, engineering is it.